for Transportation Innovator. So again, welcome, and I'm Sil. So I understand that most of the attendants today are existing customers who would like to explore more about what SolidWorks simulation can provide. So in this case, I will skip the introductions. And if you have any questions, you can feel free to unmute yourself. Yes, you can see that your name is on the side panel. There's a green color small icon say mute. So you can just click on it. You can just unmute yourself and you can ask any questions that you prefer. So today, I will be the presenter. I'm Sil Chang Wei. You can call me Sil, and I'm the product manager for simulations. If you attended any seminar or sharing that we conducted before, I believe you've seen me before as well. So without further delay, let's start our sharing on how to evaluate products manufacturability for transportation innovators. Today's agenda, first of all, let's start with some current design concern, or we call CBI, critical business issue. And then we will look into the simulations solution overview. And we shall enjoy a video to see from A to Z how the parts that we have designed in your current design software, which is SolidWorks, and how this information will channel further down with simulations. And we look into the available features that you may consider to use it, Q&A sessions, and last but not least, what we're going to have next week in the part 2 for this sharing. In simple, there's 3 types of simulations that we can consider. And to be very honest, 3 of these simulations are widely used in automotive industry. First of all, the finite element analysis, or we call SolidWorks simulations. And then we have the computational fluid dynamic, which is flow simulations. And last but not least, widely used, which is plastic injection simulations. We understand that now the plastic part is getting more and more. So in today's sharing, I will start by covering SolidWorks simulations, which is the finite element analysis, FEA, and the plastic injection simulations. So first of all, CBI, the current design concern by most of our customers. Do you have the same issue as well? More and more customers ask for analysis reports. Need to check the performance of the design. Optimize your design for weight and performance improvement. Improve customer satisfactions. And I don't have the right expertise to perform FEA. Yes, Inja, help me. Anything I can help you? If no, I shall continue my sharing. First of all, more and more customers ask for analysis report. Understand the key player in Malaysia is Proton, Perodua, and then we have the Japanese company like Toyota, Honda, and even Nissan Tanjong. Okay, they are our main customer in this region. And of course, most of you having the same issue that we have the pressure from this industrial leader, where they started to ask about analysis report. And the reason behind is because they want to improve the quality of their design. That's why they are more demanding. And this again is driven by ourselves as a consumer, because we want to have a better safety car, we want to have something more reliable, and this pressure go to these manufacturers, and they will channel down to the first tier, the second tier vendor. So that's why the concerns on the design safety and improvement is there. And of course, globalizations. Recently, okay, last week I have a customer visited us, and he shared with me that there's a project in hand, but none of a local vendor dare to take this project because of the short due date. And there's a Korean company who take up the challenge and accept this project. So this is what we are facing now. Globalizations and automotive industry is one of the earliest industry who have this globalization concern, because if today we are not competitive enough to take the project easily, okay, our neighbor country can take it, and maybe even at a lower price and in a shorter lead time. That's why more and more customers asking for analysis reports. Need to check on the performance of the design. I believe this is since the day one we have this issue. Okay. Current issue that we are facing is that we only able to measure the performance in the later stage of a production. Yes, because we cannot perform something we call upfront design validations. And at the end, we spend more time on improvement and fine-tuning, and we allocate quite a lot of budgets on the testing. If you look at this simple diagram that I attached in this slide, the blue color indicates the impact of change. The orange color indicates the cost of changes. Now, on the left, this is the early stage. You can see that in the early stage changes, the cost of changes is tremendously low, but the impact is tremendously high. Where at the end of the later stage, which is most of us are doing nowadays, and at the later stage, we spend more for later changes only. So if today you have a choice, definitely you would prefer the changes was done in the early stage, because the cost of change is tremendously low, but the impact is tremendously high. Okay. Next, optimize your designs for weight and performance. For any designer, any engineer, this is part of a KPI. We are talking about the fluctuations of a material price, and we tend to lower down the weight so that we can increase the performance. And it's very obvious in automotive industry, in mobility industry, that we all know the lighter the vehicle, the faster it can go, and it consumes less fuel. So optimization of the design and weight is again a CBI or a concern that is forever together with us, and we are continuously searching alternatives to overcome this issue. Customer satisfaction, we are talking about end user. Us as an end user, consistently we giving feedback, and of course, as a manufacturer, you would not want to have a product break down during warranty periods, right? And of course, for production line, I want to reduce high reject or rework rate. The less reject we have, the more effective and the more cost that we can save. And this is one common question for most of the managers and also the owner, that I do not have the right expertise to perform FEA. So a challenge to you all is that why giving yourself an excuse to design better products, right? They say it's very difficult to hire the right person to perform FEA. I really agree with this one, because it's not everyone have the final element analysis skill. And they say we just do it once in a blue moon. So why should I invest to get someone sitting in the office and just doing FEA? So my answer is very simple. What if the software is so easy to use that you can train your current manpower, your current user to do it, right? And I believe you answer most of the questions. Let's say you're just doing it once in a blue moon. If your user can do it, why hire more? Yeah, and you no longer need to have to hire new person to do the job, because SolidWorks simulation is so easy to use, and I will just see it as an additional features in SolidWorks to improve your design. Okay, I'll come back to this later on, where later on when we see a video, we will understand how easy is this solutions. A typical process that we can see, this is the CAD design we draw a model, we simplify it, and then we transfer out for final element analysis to do the numerical solver calculations, and we have the end result. Now, what we are proposing here in SolidWorks is that we want to combine all in one, especially for you who already have SolidWorks, who already have CAD software. Now, let's add in the FEA as additional features to your current CAD system. And inside SolidWorks, you can just a few clicks and you can have a final result in the early stage. And you can see what will be the design improvement that you need to do. And any design changes, you do not need to leave SolidWorks interface. You just change your design, it will automatically update, and you just rerun the numerical solver to get a new set of data. Just as simple as that in SolidWorks. Okay. I will use this as an example for today's sharing. So you can see this is something that we see a lot in the construction site, and this is more focused on mining or tunnel. Okay. Now what I want to focus is that at this boom, we want to design a simple knuckle. This is a knuckle design. So of course, as a designer, we want to know whether that this knuckle able to support certain load that acting onto it. And the load we're looking at around 180,000 Newton. Okay, again, 180,000 Newton of load will add onto this knuckle, and we want to know, is this design good or not? Okay. So I'm going to show you a video, a quick video, and how these simulations act in SolidWorks. So at the end of the video, I'll come back again. So this is just a 3-minute video. So enjoy the video.
Now the 125mm bore hydraulic cylinders put out a great deal of force. And in order to validate our design, we should perform a simulation on our knuckle kit to see if it can withstand the load. To do that, we'll leverage SolidWorks simulation. These bolts and washers do not add much to the simulation, so let's remove them for now. This can be easily accomplished with the selection tools to select and suppress them. We may also want to add the rod eye to this assembly to better define the load transfer. And with a quick search, we can find this part and add it to the assembly. Let's center the rod eye up with a width mate and then locate it in what will probably be the most extreme loading situation. Notice that when I add a mate between these two faces, SolidWorks warns me that the default coincident mate will not work. So we'll choose an angle mate and place it at 35 degrees. Looks perfect. Now we'll do some simulation. In this case, we'll choose to do a static simulation study. Next, we need to hold our assembly by adding some fixtures. We'll start with fixing the two end caps so that they have no movement. Then we'll add a sliding fixture to the wear place, as they are free to rotate on the support bracket. Finally, we'll apply a force to the rod eye. This will be 180,000 newtons to represent the load from the hydraulic cylinders. That's it, and we're ready to run the simulation. At this point, SolidWorks automatically meshes the parts, establishes the contact between the parts, and runs the analysis. With the fastest solvers in the industry, we're presented with the results in no time at all. The colors on the part correspond to the stress values listed on the right, but since we're analyzing an assembly of parts with different materials with different yield strengths, we'll be better served with a factor of safety plot. This plot identifies the ratio of the stress to the yield strength of each part. For our knuckle, we want to have a minimum factor of safety of 2, so we can change our chart and disregard any values above, say, 4. We can see that there are areas in our knuckle that do not meet our requirement of 2 for the factor of safety, so we're going to need to make some changes. With SolidWorks, there's no need to start over. Let's just edit the part and make some changes that will strengthen the area of concern. Let's change the thickness from 25 to 30 millimeters, and we should probably increase the size of the fillet. But remember, when we created the fillet, it included a bunch of edges that should stay the same. Well, this isn't a problem. With the fillet expert, it's easy to change individual fillets without destroying others. We'll choose these two fillets and resize them to 30 millimeters. SolidWorks separates them from the others, preserving our design intent. As we go back to the simulation, all of our loads and fixtures are intact, and all we have to do is hit run, and SolidWorks will rerun the simulation with the new geometry. As we look at the factor of safety plot, we can see that we now meet our minimum factor of safety requirement of 2. Problem solved, and we can rest assured that our part won't fail in service. Let's bring back the bolts and washers and remove the rod eye, since we already have those in the boom assembly.
Okay guys, that's the 3 minutes videos of SolidWorks simulations. Now you can see that from A to Z, the whole demonstrations is in SolidWorks interface, and we're talking about additional features that during the setup we use in the simulations. And the interface is tremendously simple, easy to learn, and fast for us as a user. So this is a tool that designed for engineers, designed for designers, designed for people like us to use it to save time, and immediately we get an insight on how we can improve our design. So again, a simple diagram showing that this is our setting. The green color indicate area that we fix or we control, we restrain. The one in purple color represent the acting load, which is 180,000 Newton acting onto this design. Where at the end, the color plot shown us at different locations, we have different stress. Red color mean high stress, blue color mean low stress, and in this case, most area is green, yeah, which means this design will not fail under these conditions. So by understanding the design through a color plot, now you know how you can improve a design. Maybe you want to add some fillet over here, you want to do some cutting over here to save material cost, since this is a casting part, right? So this is how SolidWorks play a role as an upfront design validation solutions. Okay, on top of it, before I forget, it also can automatically generate reports, which is like the one that's shown on the screen. So for people like us, yeah, we don't really spend much time on doing report. We can automatically generate reports, and this can be a supporting document to show to the management or your client that the improvement that you have did for your current design. Or let's say if you're your own reports, the good thing about this report is in Microsoft Word, you can just like copy paste into your formal reports. Just as simple as that. Okay. So I hope this simple video gives you a better understanding on how SolidWorks simulation can actually help you on improving your design. Okay. Now let's move on to plastic. As I mentioned just now, I'm going to cover 2 areas, which is the finite element analysis and the plastic injection simulations. So look inside your mold. Very simple. If you are doing plastic parts, a lot of time you want to do the injection molding simulation directly to the designer of automotive plastic parts and injection mold. So what you would do is that it will simulate how melted plastic flow during the injection process. And from this case, you can immediately evaluate the manufacturability while you are designed to reduce costly mold rework, improve the quality, and accelerate time to market.
In this presentation, let's take a look at SolidWorks Plastics, an injection molding simulation software completely embedded inside SolidWorks that helps you predict and avoid injection molding manufacturing defects during the earlier stage of the part and mold design to avoid time-consuming and costly mold rework. we are looking at a smoke detector housing, and we would study more in detail the top cover. The first thing you might want to do inside of SolidWorks is analyze this model for draft analysis. The draft is very important, and injection molding plastic parts require a draft in order to be injected properly out of the mold cavity.
So in the early stage of the demonstrations, it's more focused on the mold features that we have in SolidWorks. For example, like draft angle, putting in web to support it. So I'm going to skip the front portion to save our time because we have limited sharing time for today. So I just want to focus on the injections area, which is here.
And what's the maximum being solved?
Sorry. Okay, let's start from here.
Location. Let's just pick an edge gate at this point. After meshing the model, selecting a material and picking the gate location, we're ready to go and we can now run the analysis. After a pre-processing phase, you can see that the preview results are dynamically displayed on the screen as the analysis is being solved. It's an extremely useful feature since it allows you to see if something went wrong in the earlier stage. You can then stop the analysis, fix the problem, and restart another one. The Plastic Manager also provides some valuable feedback. You can know what percentage of the model is filled, the processing time, and what the maximum pressure requirements are. If you find out that the maximum injection pressure is starting to peak, or is simply higher than the maximum pressure of the injection molding machine, you will know at this point that this part is unlikely to be manufactured properly without a design change, a process parameter, or maybe even a material change. As this analysis is running, the results are being generated. You can also see that we have a lot of different types of results that we're going to be able to look at. Not just the filling time plot, which can be seen on the screen, but things like the injection molding pressure, average temperature, flow front temperature, or cooling time. Our analysis is now complete, and we can look more closely at the results. But the first thing that comes up is what we call the result advisor. It basically explains all the different result plots and gives you some advice on how to troubleshoot and fix any potential problem. To gain further insight, we can animate the fill time plot. Here we are looking at the profile of the melted plastic as it travels in the mold cavity. One of the major problems that we have here is a phenomenon called racetrack effect. That's usually caused by a relatively thick wall section where the plastic in one area of the part rests ahead of the flow front in the rest of the.
Okay, so far this is what I want to share about SolidWorks plastic because I don't want to go through details of the features. But I want to show is that you can see that by having a plastic part in SolidWorks, we just simply define what kind of materials that we want to use, where will be the locations of the gate locations, and at the end the software will simulate and give us quite a lot of different types of output, which including pressure at the end, the weld line, the air trap. Okay, so this is an additional features that we have in SolidWorks. We call the SolidWorks plastic, and it was widely used in the automotive industry because we all know that quite a lot of the parts in the automotive are plastic parts, and definitely it's going to help if you are in this industry. Okay, to sum up today's sharing, so what SolidWorks offer for simulation? Now what you see on the screen here is a series of features that we have in the FEA module, which is the SolidWorks simulation module. First of all, we have the static and motions, we have the vertex, there's quite a lot. So I have filtered out a few features which is mostly used by the mobilities and transportation industry, which is those in red. So first of all, static analysis. means what you have seen just now in the video for the final element analysis. That is the static analysis. And then fatigue analysis. So let's say you want to design your part for warranty. Let's say I want the parts to be available to use over 10 million cycle, and you will not want it to fail if the operation is less than 10 million cycle. Then we can use a fatigue analysis to study how durable is our design. Thermal analysis, thermal stress, because our design of automotive is quite frequent subject to heat, and it will cause heat stress. So in this case, thermal analysis. Well, the features that I like the most by most of my customers is optimizations. Yes, because this solution helps us to automatically optimize our design to again lighter weight and more reliable design by itself. Motions, if you are designing mechanical parts more towards the engine compartments or any mechanism, we have the motions analysis for you. And then if your design is subject to movements, or I would say vibrations, we have the linear dynamics and non-linear dynamic analysis. I can share with you is that I have a customer who are in this public transport design. So that's one of the components inside the vehicle is subject to vibrations. So he would like to know when the bus started to move, will these parts vibrate too much and cause a failure of the design. So in this case, we have used linear dynamic to perform the analysis, and from there they get a better insight on how to improve the design in the early stage. So this is what SolidWorks can offer in overall simulations. Well, for the plastic sharing that I mentioned just now, you can see here, this is all the features that we covered in plastic injections. And the great news is that this year, we also have launched the Plastic Advance, which now we can do the fill, pack, cool, and weld, which means a total plastic simulations module. Okay, so from here you can see we can do filling and short shots, air trap, weld line, shrink marks, and even multiple gate, where this is I call the common plastic injections features that most of the customer definitely they will going to do that. Where on the right, which is in purple in color, which is very subject to customer, but mostly they might ask for this as well, which include multiple cavity, which are doing a runner balancing. This is for those who are doing family mold, to understand the shrink gauge of the plastic parts, insert or over molding, cooling time, rough gates, okay, control, or even fibers analysis and co-injections. And again, I will not go stress too much on all the features because I have mixtures of different customers from different industry. So further down in coming webinar, I'm going to have additional webinar sharing on this product as well. So by that time, you are feel free to join, where I'm going to talk more insight about each individual features. So what next? Before I sum up the sharing today, before we go for a Q&A sessions, I just would like to let you all know that they're going to have a part 2, which is more focused on the stress and the flow. And the highlight include assembly deformations and the factor of safety, how to optimize your design. I'm going to share a video on that. Mechanical study for those who are doing mechanical parts. And for those who interest with aerodynamics, we have the aerodynamic study. And I will talk more about the fatigues, which is the predict design lifespan. So for you who attend today's sharing, please mark down that on the 25th of February, which is the coming Tuesday, I'm going to have the part 2 of today's sharing, and the time is 11 to 11:30. Okay? So with this, it ends my sharing, and I open up for a Q&A sessions. So if you have any questions, you can always look to your right, which is a task panel. You can just go to the chatting column and write down your questions, and feel free to answer questions. So I'm going to spend 3 minutes for Q&A sessions. So feel free to ask. Injek Helmi, do you have any questions? Kalau you nak tanya pun boleh tau. You can unmute yourself and you can always ask questions. If you don't want to type lah. So no questions from the attendants? Well, in this case, that's a good news for me as well because means I did a good sharing. So after this, when at the end of the sharing, it will pop up a survey. So feel free to fill in the survey form and we'll know how we can improve ourselves for the coming webinar. Also, after today's sharing, our colleagues, mostly from marketing side, will send an email and contact you all to follow up, see what is the next action that you prefer us to do. Most of the time, customer will prefer us to do an on-site visit and to do some sharing or even a demonstration. Feel free to request and we'll try our best to visit you. With this, I'm on time. I just completed my sharing within half an hour and I hope you enjoyed the sharing sessions and have a great day. So bye bye.